What if, pinasa lang tayo ni sir kasi naaawa siya sa atin? What if, pinag-reporting tayo ni sir panghatak ng grade natin kasi mahihirapan tayo sa finals? Or what if, pinagawa niya to lahat kasi exempted na tayo sa finals? Ikaw sir, anong greatest what if mo?
I'm Rigelan G. Abacan and pag-aaralan po natin ang layers of the atmosphere and ang relation po nito sa aerodynamics. So the Earth's atmosphere is divided po into 5 main layers and 4 transition layers. The first layer is the troposphere, which is the lowest region of the atmosphere. Its height is about 6 to 10 kilometers. And the top of the troposphere is called the tropopause. The second layer is called stratosphere, and it is located between approximately 12 to 50 kilometers above the Earth's surface. And the top part po ng stratosphere is called the stratopause. The third layer is the mesosphere. So it is located between about 50 and 80 kilometers above Earth's surface. And the mesosphere gets progressively colder with altitude. And the boundary layer of mesosphere is called the mesopause. So the first layer is the troposphere, second the stratosphere, and the third mesosphere. So the fourth one is the thermosphere. It is located between about 80 and 700 kilometers above Earth's surface. And the transition layer of the thermosphere is called the thermopause. So lastly, the fifth layer is called exosphere. It is located between for about 700 and 10,000 kilometers above sea level or above the Earth's surface. In relation to aerodynamics, ang atin pong mga airplane ay nagtatravel sa layers ng troposphere and the stratosphere. Light aircrafts like helicopters typically fly in the troposphere, wherein dito po na-encounter ang turbulence dahil sa layer po na ito, nandito po yung mga water vapor na nagfo-form ng clouds. And these light aircraft are unable to operate at a high altitude because they lack pressurized cabins. So unlike large commercial aircraft, they prefer po to travel in the stratosphere where they can avoid bad weather. Another thing po is aircraft typically fly at high altitude because less dense po ang air at high altitude, resulting the aircrafts can fly faster and use considerably less fuel.
Hi, good day. My name is Ralph Lawrence Elquan, and today we're going to talk about altitude. So, what is altitude? So, for me, what comes on my mind when we were talking about altitude, this is the height of an object or point in relation to sea level or ground level. So, basically, altitude is just like an elevation. It is basically the distance a bit above the sea level. So, fun fact also about the aviation industry that do you know that the common cruising altitude for most commercial airplanes is only between 33,000 to 42,000 feet above sea level? Why? Because it is the safest range of commercial airplanes to fly above sea level. High density altitude has a harmful impact on aircraft performance. Why? Because first of all, it reduces lift and impairs propeller efficiency, so it reduces thrust as a result. And then high density altitude can also decrease the engine's power output. If it's not accounted for, increased density altitude can cause major problems during takeoff and landing, and also a lot more. So the higher the altitude, the longer the distance of the air molecules, meaning less pressure. So the air becomes less dense than the air near to the sea level because of the air molecules are very far from each other. So this is also what the mountaineers mean by thin air. So thin air exerts a less pressure than the air at a lower altitude. And this even goes beyond knowing that life is different if we are flying in the mountains compared when we are at a sea level. The effect of the drag are all part of best operating an aircraft either at high altitudes or closer to the ground. So generally speaking, flying at high altitudes means higher airspeed because of less drag.
Hello, good morning po. Ako po si Bash Noel Aranyas ng AMT 4-2 po. Bale, i-discuss ko po is about po siya sa angle of attack. The angle of attack is the angle at which the chord of an aircraft's wing meets the relative wind. The chord is a straight line from the leading edge to the trailing edge. Bale, yung angle of attack po is siya po yung angle kung saan ang atin pong aircraft ay nakakapag-produce po siya ng lift before flying po yun. So bali siya po yung angle kung saan yung aircraft po natin yung nakapag-produce ng lift. At nangyayari po yung pag-produce po ng lift kapag po yung stream po ng hangin ay tumatama po sa wings ng aircraft po. Yun. Nagsasanhi po ng pag-produce na po ng lift. Bale, yun po yung tinatawag na angle of attack. Yung angle po ng aeroplano na pag ganun po. Tapos, tatama po yung hangin dito. Nagpo-produce po ng lift pag ganun. Habang nagpo-produce po ng thrust dito sa likod, ay nagpo-produce po ng lift habang sumasalpok po yung hangin pag ganun. Bale, yun po. Yun po ang angle of attack. Thank you po.
The four forces of flight are thrust, drag, lift, and weight. Lift is the force that opposes the weight of an airplane. Ang wings ng isang airplane ay airfoil shape. Dahil sa airfoil shape na ito ay nagge-generate ng lift dahil may pressure difference na nangyayari sa wing. Drag is the aerodynamic force that opposes an aircraft through the air. Ito yung hangin na tumatama sa ating airplane sa tuwing ito ay lumilipad. Next is thrust. Thrust is the force that moves the airplane forward through the air. Ang thrust ay nag-generate ng propeller and ang propeller ay nakakonect sa engine. And lastly, weight. Weight is the gravitational attraction of the Earth on any object. Kung sa Tagalog ay ito ang bigat ng isang bagay.
So ngayon, pag-usapan naman natin kung anong airfoil. So, ang airfoil ay dinesign siya sa ating aircraft para makapag-produce ng lift. So, kailangan airfoil shape ang ating wings or fuselage para masabing airworthy ang ating aircraft. So, ano nga ba ang mga parts ng ating airfoil? So, meron tayong trailing edge and leading edge, upper and lower camber, and meron tayong tinatawag na chord. So, si leading edge, ito yung front part ng ating airfoil, and si trailing edge, yung back part ng ating airfoil. So, pag dumaan yung wind, syempre unang tinatamaan dyan is yung leading edge, and yung pinakahuling tatamaan dyan is yung ating trailing edge. So, yung chord naman, siya yung imaginary line simula leading edge papunta kay trailing edge. Then, si camber naman, ito yung curve ng upper and lower part ng ating airfoil. So, si upper camber, siya yung upper surface ng ating airfoil, and si lower camber, siya yung lower surface ng ating camber. Then si camber nga pala yung curve ng ating airfoil, and nakaka-affect din yung camber natin sa pag-produce ng lift ng ating airfoil. So, kailangan bilang aircraft maintenance, kailangan alam natin yung basic knowledge sa airfoil natin. Kasi kung walang airfoil shape, malamang hindi airworthy or hindi lilipad ang ating aircraft. So, yun lang, and thank you.
Hello, my name is Tarek Vinyas, and now we will talk about Bernoulli's principle.
But to further understand Bernoulli's principle, we must first talk about lift. In order for an aircraft to rise into the air, a force must be created that equals or exceeds the force of gravity. This force is called lift. In heavier than air aircraft, lift is created by the flow of air over an airfoil. The shape of an airfoil causes the air to flow faster on top than on the bottom. The fast-flowing air decreases the surrounding air pressure. Because the air pressure is greater below the airfoil than above, a resulting lift force is created. And to further understand how an airfoil creates lift, it is necessary to use two important equations of physical science. The pressure variations of flowing air is best represented by Bernoulli's equation. It is derived by Daniel Bernoulli, a Swiss mathematician, to explain the variation of pressure exerted by flowing streams of water. The Bernoulli equation is written as pressure plus 1/2 rho times velocity squared equals constant. To understand the Bernoulli equation, one must first understand another important principle of physical science, the continuity equation. It simply states that in any given flow, the density times the cross-sectional area of the flow times the velocity is constant. The continuity equation is written as density times cross-sectional area of flow times velocity equals constant. Using the Bernoulli equation and the continuity equation, it can be shown how air flowing over an airfoil creates lift. The Bernoulli equation states that an increase in velocity leads to a decrease in pressure. Thus, the higher the velocity of the flow, the lower the pressure. Air flowing over an airfoil will decrease in pressure. The pressure loss over the top surface is greater than that of the bottom surface. The result of the net pressure force in the upward direction creates a pressure force called lift.
Huwag ka na mawala, huwag ka na mawala. Ngayon, dadaling kita sa may bahay. Di